Hi everybody. Today we're going to talk about solutions, solubility rates, and acids and bases. We are starting our new unit, and we're first going to start with a solution. And when you think of solutions, go back to the unit that we did with matter, where we talked about homogeneous versus heterogeneous. Would a solution be homogeneous or would it be heterogeneous? Think about that one. Okay, now when we look at the definition, a solution is homogeneous. For those that thought homogeneous, you are correct. It is a homogeneous mixture, which means it's the same throughout. So when we look at this one, for a substance to be dissolved into another to create the solution, then we look at solubility. And solubility is for substance such as a solute, right here, a substance, to be dissolved in a solvent. We're going to identify these parts in just a second. Okay? And over here, this chart identifies different ways that you can have solutions, like a gas and a gas could be homogeneous, could be like the vapor in the air, liquids into a gas, forming clouds, foams, aerosols, and sprays. And liquid in a liquid means it's miscible. Okay, solid into a gas would be smoke or the particulate particles. Solid into a liquid would be some kind of insoluble particle in there, sort of like that precipitate that fell out. Or solid into a solid would be making stainless steel pots and pans. Okay. Now, the parts of a solution that we have up here, there are two major parts. The first part is called a solute, and that is the part that actually is being dissolved. Okay, so a solvent or the solute, excuse me, could be like hot chocolate, as in this picture up here, or it could be you dissolving sugar into a liquid. Okay, or it could be salt. Okay, another one is a solvent. A solvent basically is a part that does the dissolving. So the universal solvent that's out there is actually water. But you can have other liquids, such as alcohol. If it is an alcohol-based solution, then it is called a tincture. So like iodine solutions that you put on your cut is that. Okay. Now, there are some factors that affect your solubility, and here they are, the two right here. The first one is called polarity, and a good way to view that, again, like the north and south poles that we have, but basically these particles are sticking together. So polarity is when one object will stick to another, then it is showing polarity. Like objects will actually dissolve into other like objects. Okay, temperature also affects solubility rates. We're going to do a lab today that will show how solubility rates are affected. So like temperature can be, if you increase the temperature of the solvent, let's say water, then other things can dissolve into it a lot quicker. There are some levels of a solution. First of all, the first one is called unsaturated. So that means like you drinking unsweet tea and you're like, oh, it is just not flavorful. So you add a little bit of sugar. You taste it. It's okay, but you could add more. So an unsaturated means it's holding very little solute into that solution, and a lot more solute could be added and could be held in that solution. A saturated means it's holding all the solute it can hold at that given temperature. And then you have supersaturated. That one is the most saturated at that point. It's actually you're increasing the temperature. It's very unstable. You're holding more solute in that solvent than it can hold at that particular time, and you're having to increase its temperature. Now, if I were to draw a little line here, later we're going to have and identify it. If I were to draw a graph right here, and I draw a little curved line showing things being dissolved in there. There are 3 points that I could draw on there. One up here, one on the line, and one below the line. Okay, so the one up here, that first point would actually be supersaturated. It's holding more than what it can hold at that given temperature. A saturated would be one that's actually on the line, and unsaturated would be below the line. Okay, now we also have some solutions. The first one is called an electrolyte. We kind of mentioned a little bit with this. Electrolyte is a solution, and it can actually have something dissolved in it, and it actually can conduct electricity. So when you add salt to water, it actually can create an electrolyte solution. Gatorade is another great example of that as well. A non-electrolyte solution would be, okay, I've got a solute, as in sugar, and it's going to dissolve into the water, but it doesn't conduct electricity. Okay, so those are the two right there. So electrolyte, think of electricity. Non-electrolyte, no electricity. Okay, now we also have concentrated and versus diluted. Okay, so what we have right here, a concentrated solution is very, very, very strong. It's sort of like drinking extremely sweet tea. Okay, and then a diluted one would be, okay, you get that Bojangles tea, you drink half the tea, the ice melts, you go to drink it, and it's watered down. It has that watered down flavor. That is a weak one. So dilute a solution, you basically add water to it. Okay, you add water to it. Okay, now the last slide for today is how to speed up. How do you get a solute to dissolve into a solvent quickly? Okay, so the first one is actually stirring, sort of like what this chef is doing up here with this pot. If you have a substance in there, you stir it, and basically it's going to dissolve in there very quickly. The other one's heating. So in the same picture right here, he's got a fire, heating it, and the solution is actually dissolving in there. The last one is powdering. Here you can see I have sugar cubes and then actually granulated sugar. So if I take that granulated sugar right there and put it in there, it's going to dissolve a lot quicker than that actual sugar cube. Now this leads us into our lab for today. We're going to actually take some sugar cubes and we're going to introduce them to heat and stirring to see if it can affect it. Okay? And I hope you enjoyed the lesson for today.